see a competition more of an encouragement for everyone to take part in these activities. Start with something that you have not done. So that was the whole idea, and hope you enjoyed. Unfortunately, we wanted it to have on the campus at IIIT Bangalore, but because most of the submissions were online, and a lot of you told if we could have it online, um, uh, we thought we'll make it completely online. So maybe next time when you're in Bangalore, maybe we could do that. So before we begin, we'll start in just 10 minutes with the evaluation. I just want to show something regarding IEEE GRSS and what the participants had built. Where are they from? All these things we'll go over. So I'm just showing some metrics as of now. So 33 teams had registered, and these 33 teams had 66 participants in total. All these participants from different backgrounds and different areas of India. So these are the final teams that will be participating. You see there are 15 teams here. Out of them, one backed out at the last moment, but no worries. But we encourage them to take part next time. So these teams, according to the list, the hierarchy will present today. Okay, so the evaluation criteria will be on three main bases. There are evaluation criteria which I'll also show, and the jury will decide on that. So each team has 5 minutes of presentation, and then followed by, if jury have any questions, not necessarily they need to have questions, but 5 minutes of Q&A by the jury, and then they need to enter that their marks into this sheet. I'll show where the sheet is. So these are our jury members. It is an esteemed panel comprising of industry and academia with experience. So now I want to highlight the student category. So where the students came from for the participation. So most of them were from MTech, and many were from BTech, which is encouraging because we want students from get-go to from BTech itself to start applying these techniques, and various others from MSc, PG diploma, PDF, and PhD as well. Now this is one of the map that we created. I want to show where are the participants from. So if you can see, we are all across India. So as you can see, a lot of them are from Karnataka, obviously, but because it was more encouraged here. So you can see a lot of universities: Karnataka State Application Remote Sensing University, IIIT Bangalore. There is also NIT Surathkal. There is IIT Bombay, Symbiosis, IISER Bhopal. Then you also have lovely professional university at the top, Banaras Hindu University, Birla Institute of Technology, Aliyah University from Kolkata, Odisha University. So it was a mixed bag of participants. We had a fun time talking with you all. Hope you win the prize, and um, even if you don't win, I think you take the feedback positively and keep participating, never lose hope. So with that, I think we can start with the presentations. Also highlight the evaluation criteria. So each juror will have one sheet to submit. So there are 60 marks for the submission, and this is the categorization of those marks. So out of 60 marks, 10 is based on your problem statement and the relevance to the theme. So you must highlight what theme are you using, because that is the whole agenda of this hackathon. Then you have to highlight your data preparation methodology and analysis, the steps, and your results and data analysis. So this includes the maps. These are the final results that you say, inference and results. So here it becomes conclusion and what future action you plan to take. So your presentation should only be of maximum 5 minutes. We'll be recording the time once you start. So it should not be less than 2 minutes as well, or else you have 0 marks. I welcome the jury now. So the jury consists of Dr. Chamlal, Ujwal Verma, Guru Datta, and Dr. Shilpa. So all are present here, I think. Yes. So if the jury confirms that we can proceed, I think we can start with the presentation. So the first team is Mizutaki. Um, so this team comprises of two members. Both are studying MCA. So they built a project called as cyclone detection. So I'll hand it over to you guys. So Nishikanta and I think Pahuldeep, you guys can carry over and share your screen.
Good morning, everyone. Respected jury members, we are Team Nishikanta. I am Nishikanta from Bagrecha, and my teammate is Pahuldeep Singh from Hillview. And our topic for presentation is cyclone detection for disaster management using satellite images. So, moving forward, this will be our content for this presentation. Coming to the introduction part. So, what is disaster management? Disaster management is preparing and responding and recovering from natural or man-made disaster. So, during these emergencies, GIS and remote sensing can aid us in decision making and provide support in disaster management. So, and coming to the cyclone detection part. So, what is cyclone detection? So, cyclone detection is detecting cyclones um, from satellite images, that is if there is any cyclone present in this area or not. So our problem statement is developing tools and strategies to improve disaster management. In this case, we are focused on cyclones. So our objective is to develop an application for disaster management incorporating with sustainable development goals. So this is our proposed solution. So our proposed solution will consist of an object detection model to identify cyclones from satellite images, hence giving an early warning about it, so that authorities can take appropriate action to minimize the loss. So it incorporates two SDG goals, that is SDG goal 9 and 11, which is industry, innovation and infrastructure, and other one is sustainable cities and communities. So this is our methodology for this project, that is creating training dataset pre-processing, training the model, and then recognizing output and performance evaluation. So coming to the dataset, we consider two datasets. One is from Mosaic dataset, which is meteorological and oceanic satellite data archival center. We used insert 3D in infrared band to convert the dataset from the archive. It was one sample list from that. This is our dataset. We have collected around 2000 images of 5 cyclones. And our second dataset is from US government dataset, that is National Oceanic and Atmospheric Administration. We have collected from two satellite data, that is Meteosat 7 and Himawari 8. Then coming to the data pre-processing page, we annotate each images, that is where is the cyclone in this image, and we split it to train and test data. And then we have selected YOLO-V8, which is state-of-the-art in object detection, and which is the latest model. Here is the code for that. After training the model, we got a precision around 0.96, which is very good. For test result, and this are some test results we applied in the validation scene. So here you can see it is detecting cyclone from this image. From this image also, from cyclone detection. We applied it to video also. So as you can see, it is correctly detecting cycle, but there are some wrong predictions also, which can be improved further by adding more training data. So these are our future scope. Our future scope is to improve accuracy by adding more data. These object detection methods can be applied to other disaster management scenarios like forest fire, flood, tsunami, and drought, incorporating with time series data. So these are our references. Thank you.
So now we will like to uh, say like question answers. If anyone have any question answers, we are uh, thank you. Tell like question.
Thank you, team. Jury members, this. So I've also attached on the chat their project link, which is added on the GitHub. So if you guys have any questions, I think we can take questions.
Thanks, Aman. Thanks, team, for the presentation. Uh, it's a very important topic. It's a very interesting topic that you have worked on. My couple of questions from my side is there are some false means you have missed detecting the cyclones in few of the cases. So right now you have used a standard model of YOLO. Uh, what do you think could be the possible improvement in this model that would be able to detect the cyclone more accurately?
Yes, sir. In case of using the object detection model, we can use like image segmentation methods, which can be more accurate. And we can also try with other models, but due to the time constraints, we could not experiment it with them.
Yeah, the second solution we can achieve is by RCN and SSD models, which can improve the models, but uh, YOLO 8 is the current and newest architecture, so this incorporate the more improved version as compared to others.
Okay, um, that's fine. And did you use the data set that you have used from NOAA? You manually annotated yourself, or it was already provided the annotation?
No. We manually provided. We manually annotate those images.
Okay. Now, one question from my side is in all these images, uh, even a simple visual inspection can say that, okay, there is a cyclone here. So what do you think the purpose of your method could be? Where exactly it could be helpful?
But in that, as you said, one visual inspection, that is, there was some human will be present who is inspecting the satellite
Mhm.
images. So we are automating that task.
Uh,
Yeah, the
okay.
model can automate everything. If you can stream data directly from the satellite, we can
Mhm.
apply the model on that, and it will predict that if there is a cyclone, it will give warnings.
Okay.
Yeah.
Okay.
Or
What do you think? Go ahead. Go ahead.
yes, sir. And so this method can be used for some similar kinds of disaster management. For example, like forest fires. So if there will be, if we're monitoring a region, let's say on forest, if there will be some forest fire, this method also can detect that and give us warnings.
Okay. So You have already said that this method can be extended for detection of forest fires and other disaster management
Frauds, yes.
application. But apart from that, any other future direction that you see?
Yeah, future direction is to incorporate time series data. To it is we have not included the time in it. So if you can include time series data, it also can help us to predict the future.
Mm-hmm.
and
Like
and I was also like to include we can use different uh, translations in maps. For example, in NOAA dataset, the images, the cyclone images are far.
Mm-hmm.
So we will uh, change and do the image registrations of two different satellites to improve the uh, maps and improve the accuracy of cyclone detection or any other uh,
Mm-hmm.
area in disaster management.
Okay. So just one final remark from my side. Don't you think it will be better to predict the cyclone than to detect it? That means, would it be better to have a model which can predict with some accuracy with certain time frame in advance rather than just detecting it on the satellite image? What do you think about it?
yes, sir, it will be a very nice area to explore, but we need, like I said, we need more data like humidity, temperature, and ocean currents. All these
Mhm.
things we need to predict. So, yeah, we can extend this project to go in that direction, but we need more data.
Okay, good.
Yes.
That's it from my side, Aman.
Thank you, sir. If any other jury have remarks or any questions.
Only a single question from my side. Most of the things were already been discussed. You have made a statement in the slide wherein you're discussing about improvements and future scope that you have it provided some comparable accuracy but can be improved. So you have compared your method with what all methods, with what all existing methods.
We first tried the simple miscellaneous methods with OpenCV, like from the wind
Simple.
speed. Miscellaneous methods, like if there will be some wind speed above 150 or 200, then it may be a cyclone. It was only based on the statistics, but that doesn't give any good results, so we go for the objective detection method using
So
UWDate.
have you compared with any of the recent methods which are used for particularly this application for cyclone detection? There are so many methods which have been devised. Have you made a comparison with that?
No,
If you have not made such a comparison, it's not appropriate to make such a comment.
yes, ma'am.
Yes, ma'am. Actually, we try to find the some research papers for our model to compare with, but it was uh, uh, like not able. We did not able to find the uh, uh, methods which incorporate object detection. Uh, like there are some research work or methods which do interpolations and predict the uh, uh, like using line-based methods to predict the cyclones in future outcomes in the region, but uh, like object detection is we did not uh, incorporate like in see that.
Okay, fine. But still, I recommend you to have a look on the recent literatures because there are so many deep learning techniques which are being used for the same application. So a fair comparison will be well enough to make that kind of a statement. Just have a look.
Okay. Yes, ma'am. Thank you.
That's all. Thank you, Pramilpa.
Thank you, ma'am. I think now you could add the marks, the scores on the sheet, and once you're ready, I think we can then go on to the next team. Geo Pioneers, there are a team of two members, Sohan and Poonam. So they are studying MTech. So guys, you can share your screen and we'll get started. And please be quick, within 5 minutes. There are a lot of other teams as well. Yes.
So screen is visible, na?
No,
Yes, yes.
I hope I am audible.
Yes.
Yes. Namaste, everyone. Myself, Poonam Revre, and I have my team member Sohan Kanse with me. Our team name is GeoPioneers, and the topic we have chosen is integrating PyQGIS and geospatial technology for soil erosion modeling using Russell model, that is revised universal soil loss equation. Sohan, I guess the screen is not visible. Yes, so the objective of our proposed study is identification of the soil erosion zones at the Upper Krishna Basin, quantification of the soil loss at the Upper Krishna Basin, and modeling soil erosion using Russell model at the Upper Krishna Basin. Addressing the issue of related to water quality and integrating water management. So this is a news article from Times of India dated 7th August 2021, which pinpointed that the flood is the major problem in Krishna River Basin. The major reasons identified is silting. So hence there is a necessity of quantifying the soil loss and identifying the major zones of soil erosion. So we think that silting causes floods along the Krishna River. So quantifying this soil loss around the Krishna Basin is much of an important topic right now. So next. As you can see, this is the global scenario of the degradation of the soil, and as you can see, the circle that is highlighting is the India, where the severe soil loss degradation is happening. This is the source where we got it from, was the Encyclopedia of Soils and the Environment. The Krishna Basin. The Krishna Basin extends over Andhra Pradesh, Maharashtra, and Karnataka, having the total area of 258,948 square meters, which is nearly 8% of the total geographical area of the country. The Krishna River rises in the Western Ghats at an elevation of 1337 meters in the north of Mahabaleshwar, about 64 kilometers from the Arabian Sea, and flows about 1400 kilometers and outflows in the Bay of Bengal. The methodology we adopted was the left-hand side is the data we collected from, that is LULC from this ISRI Sentinel-2 10-meter data, where we calculated the cover factor, FAO, soil type, the soil erodibility factor, rainfall, that is IMD data, R factor, in the LS, that was calculated, slope length and steepness factor, and practice factor, which was considered using a lot of factors. So using all these factors, the soil loss at the Upper Krishna Basin was calculated, and these were integrated into Python QGIS code and computing by multiplying each of the layers. I would like Sohan to continue the presentation.
Thank you, Poonam. So here is the basic scenario of the means. We all know that the PyQGIS is a Python extension of a QGIS. So here we can use a Python for spatial analysis, data management, etc. So here is the detailed methodology of our project. So first we have derived the variables such as the factors which is mentioned by the Poonam, the R, LS, PCK, etc. So here we have used a raster calculator calculating calculating. So here is the study area map which we have chosen, and the factors which we have got, we have submitted the detailed report on this. So here comes to the conclusion. So we have got around 2.20 tons per hectare per year soil loss in the in the upper Krishna basin, and there are various models used for the soil erosion modeling. So we have choose this model based on the previous studies done by some of the scientists, etc. So we have seen that the Russell has got the highest majority. So thank you.
Thank you, team. It just extended over time, but I think it's fine. Just 5 seconds more. But make sure to have it within time. So, jury, like, if you guys have any questions, I've also attached the link to their project on the chat.
I have one question from the team. Could you go back to the parameters that you selected for the modeling purpose? The slides you have shown on the previous one, yeah. So
Yes,
why
sir.
exactly did you selected only these particular parameters?
So firstly, this is the model built by means the pre-built. There are the soil erosion models which are the SWAT model and the ASAL model, but this model is the highly suitable, and it give means I takes only such 5 factors only.
So these model, don't you think it will be a location based? It will vary from location to location.
Yes, sir. So it depends on the soil type and the soil type, slope, etc. Slope and the elevation, the rainfall in that region, etc. So it changes according to the spatial variation. It changes.
Okay, so you have factored that in your program there, right?
Yes, sir. Yes.
Okay. Okay, that's it from my side.
Thank you, sir.
Okay, sir. Yes.
Okay, so I think those are the questions from the jury. So we'll just give 1 minute for the jury to enter the marks, and we'll start with the next presentation.
Yes. Thank you.
So yeah, thank you, Sohan and Poonam, for your presentation.
Thank you.
Okay, so I think we'll continue with the next team. The team is GeoRSS. Team members are Raghavendra and Zubair, that's studying MTech at KSR-SAC. So over to you guys. Please continue the presentation.
Namaskara everyone and very good morning. We are team Razu from KSR-SAC MTech. Our topic chosen was spatial temporal analysis of surface water quality parameters using satellite imagery. I am Raghavendra SP studying MTech at KSR-SAC, and my friend Zubair Ahmad is also in the final year of MTech in KSR-SAC. So the Sustainable Development Goal number 6 states clean water and sanitation, addressing the issues related to water quality and integrated water management as a core of standard. But the underlying fact is we have to go beyond this and monitor the quality and sustainability of water resource, which are critical for survival of people and planet. It is not just the water we provide to them, it must be of the BIS standards as such. So this is the theme which was chosen by us. So the problem statement is evaluating the water quality using the in situ data collection is a laborious process, and the outcomes obtained with respect to the accuracy is too low because the sampling size for a wide range can't be done in an effective manner, and interpolation or other techniques applied over there gives a very low accurate data. So in considering this, the satellite data is boon for acquiring the accurate parameters for wide range in terms of time and area. Keeping this in mind, we formulated the statement as spatial temporal analysis of surface water quality parameters using satellite imagery. So the area of interest chosen was the Arkavati River. Arkavati River, where the Bangalore people shun their face due to the stinking smell due to their own outcomes. is a live source for the Kanakpura city, which is located 55 kilometers from Bangalore. This is the major source of water for the household purpose and even for the croplands which is surrounding the basin. This is the most stressed water body in and around Bangalore due to the effluent discharge into it, the industrial wastewater let into it, and other crop waste and fertilizer waste let into the river as such. This has been exploited to a high extent. So this area was chosen for our study. So this image by this is done. This is the overall research conducted by Pani, where you get the synaptic view of all the parameters of the Arkavati river from its origin to the to the area covering it and the length it moves through. So the data sources and the upcoming slides would be taken up by Zubair Ahmed.
Okay, thank you, Raghavendra, for setting the context of our topic. So, next thing is data sources and tools. So, the data source is open data registry from where we are extracting the Sentinel-2 MSI level 2 data set. And the APIs which we have considered for our for our topic is PyStack client, which is mainly used to extract the data like by querying with respect to certain metadata. Then RIO X-ray is mainly used to perform certain spatial operation like geospatial operations such as clipping and all. Then stack is one more API where we are stacking the entire time series of data in form of a stack so that we can perform our analysis of our entire data set. Then X-ray is mainly used to convert the data which usually come in form of a data array to data set. Then GeoPandas is the library where we have used to handle our vector operations. Then Matplotlib was the library which was used for visualizing the data set and the time series plots. And the softwares which we are used are QGIS and Google Colab. Can you go to next slide? So coming to the methodology part, so in methodology we have two parts. One is data extraction and spatial temporal analysis. So first, the data is extracted by filtering with respect to date, metadata, and the point of intersection. So once we extract the data, then we are creating a rectangular buffer around the point of intersection and clipping. After that, we are mapping some certain water quality parameters over the entire time series of data set. So the next step is the spatial temporal analysis. So here first we created we did some random sampling using a sample size of 4 cross 4 pixel over the entire study area. Using some visual image interpretation technique in QGIS.
As the parameter studied as such, the turbidity index, the turbidity in NTU, NDSI, and chlorophyll index and pH. Through the research reviews, we got to know the various indices and the formula was formulated as such, and the regression analysis was done for finding the turbidity unit. So these are the maps, thematic map representing the various parameters. This is the NDTI in terms of, this is turbidity in terms of NTU. This is the time series analysis for the three years range which we conducted. And this is the normalized difference turbidity index thematic map. You can see the variation with the legend as shown. And this is the time series plot. See, you can see for during the lockdown region, the turbidity was too low. So this is very evident that this type of data evaluation using satellite imagery is a boon. This is the pH parameters we studied. This river is shown, the pH is optimal as such of the BIS standards, ranging from 8 to 9. And this is the chlorophyll content variation due to the algal bloom in those regions due to the discharge of the various fertilizer and all the biomass from the crop waste. Another index studied. This is the time series analysis of it. And the conclusion part is, as the Arkavati river is the main river that feeds into the Kaveri basin, and this is the main source of water, and the crop areas are irrigated through this water source. It is very essential and important to study the water quality parameters, and that too using the spatio-temporal analysis using the satellite data can pinpoint the pollution source and suggest the corrective actions to enhance the water quality. So these are the various references and the journals we referred for our study. Thank you.
Thank you, team. Now I'll ask judges if you have any questions for the team.
Could you go back to your could you go back to your methodology slide number 6? So this sampling means the parameters that you took for your project. You obtained what was the source of that information?
Uh, Actually, that random sampling is nothing but the polygons which we draw on our study area, so that we can sample out some representative sample out of those water quality parameters, so that we can plot the mean time series for those parameters.
Yeah, I understood that, but what was the information? Did you derive these parameters, turbidity, pH, from the satellite images?
Yes, we derived it from satellite images based on the research conducted by various researchers. Like we use the regression equations, correlation regression equation, which was developed by some researchers. As you can see here, we have mentioned their references as
Okay.
well.
Okay, fine. And this you limited for a particular region, particular river.
Yes.
Do you think what could be the future direction of this work?
Future direction of this work is like, I think we can improve the results more. I feel like, since the equations are developed for some different regions, so I think like we should develop these equations, like we should fit some curves for the institute data and the remote sensing data for actual regions, so the results can be more accurate. And we should include other we should do a curve fitting on other parameters as well, such as fluoride, chloride, which are like indicator of hardness. I think that those all will be the project scopes, future scopes.
Okay, so these parameters, the model that you have developed is region specific at the moment, right?
Yes,
Yes.
sir.
Okay, okay, good, good. That's it from my side.
Thank you, sir.
Thank you, sir.
Yeah, just quick questions. This from Dr. Shyam. How you have implemented the algorithm? How you have done regression analysis?
Sir, regression analysis was obtained from the research paper we read, sir. The institute data for this region isn't available for us to do, and the time schedule was too less within 1 day. So the regression equation we obtained is from the research journal we read.
Okay, in this turbidity, what is the here? What is RRS 665? What does it mean?
It means the band, sir. 665 stands for nanometers, wavelength of the band.
Okay, and right side call that constant, right?
Yes, sir.
Yes.
What is the source of this? I mean, this formula. You did not
Uh,
include it there.
it's there
It
in
will be
the
same
last
as
slide.
above.
It's there in the last slide, sir. In references.
Okay, you can cite there also. That will be
Yes,
better,
sir.
right?
Yes, sir. Yes, sir.
Yes, sir.
Oh,
Okay.
okay.
Thank you, sir. Now we'll have judges give marks, and the next team, please be ready, which is PyGeo AI. So this is
Yes.
team ID 12. The team members are Pyare Lal and Akash Singh. They are both pursuing PhD.
Not
One is
both,
PhD.
sir. Yeah.
Okay, one
One
is
is
PhD, one is PRF. So I think we'll now continue with their presentation.
So I have chosen the topic under the sustainable goal 13, which is climate action, and I have chosen like problem statement of the forest fire monitoring. So forest fire monitoring is a growing concern nowadays because of the climate change. There is a lot of loss due to the forest fires, life as well as the lot of natural materials. So this the area, study area I have given is the Uttarakhand, and this is the save file of that. And for this study problem statement, we have divided into the two parts. One is post-fire monitoring, and for the forecasting of the fire. So for the post-fire processing, I have used the NBR index, which is very similar to the spectral index as a NDVI, and shows the indicates the burnt area of the large fire. And then there is NBR, which is just the difference between the pre-fire and the post-fire. So this is for this our study area for Uttarakhand. We have chosen this for the post-fire processing. There was a huge fire in the 2016, and there was like area burned 4,538 acres, and 7 people died in this this fire. And even after for the 1 or 2 weeks, the fire went unnoticed. And this one is DBNR. Difference between the normalized burnt ratio. So for doing the analysis part, I have chosen small area, and to get the statistics, how the severity is defined here, I have these are the legends, and these are the statistics of this area, this small area I have chosen. So we can see here that under this area, there was like 49%, nearly 49% of the area was under the high severity. The next, Akash will present for the forecasting part.
Okay, so basically what we have done is that we have first taken the NBR data from Google Earth Engine, and then we have used the data to predict forest fires. This is called nowcasting with prediction in near future. So we have taken images and we have done prediction using already existing transformer based neural network. It is called Earthformer. So Earthformer, they in their original implementation. So this is a storm data set, and as you can see in the figure at the bottom, this is a time series data. So we can see how the storm is evolving, and the data is taken at 10 minutes intervals. And so what we have done is that we have, instead of the storm dataset, we have tried to use our NBR dataset to see if we can predict forest fires rather than storms. So what we have done is that we have taken 5 large images of the Uttarakhand, as you can see on the left side. And we have then subdivided these images into smaller images of 3D4 by 3D4 pixel resolution. Each of these smaller images were then compiled into an HDF5 file for the training. And basically, yeah. Okay. So, and then we try to train the Earthformer model. Next slide, please. Okay. So we trained the Earthformer first on the Sevi dataset, which is a default dataset, and to check whether the our implementation of Earthformer is working. So it did train on the default dataset, but unfortunately we were unable to train on our own NBR dataset because a specific metadata file was required by the model, but which was not present, and we could not generate it in the time constraint. So given that metadata file, the Earthformer should be able to predict forest fires in the near future. So that is our presentation. Thank you.
Thank you, team. And now last judges to ask questions. And we are also running out of time. So I think all teams and also judges, if you can keep it short. So we are left with 7-8 teams more. So yeah.
Nothing from my side.
Okay, sir. Any other judges have to ask questions, or else you can enter your marks, and we could move to the next presentation. All right. Thank you, PyGeo AI team, Pyarelal and Akash Singh, for your presentation.
Thank you. Thank you.
Thank you.
We'll move on to the next team, which is Echo Warriors. If that team is with us.
Yeah, we're there.
Oh, okay, great. So team ID 17, Echo Warriors, Brittany, Naomi, Manas, and Kirtana B, and Guru Prasad Panigrahi. all three are studying BTech. So you guys can share your screen and you can start your presentation.
Good morning. Our topic for today is IoT smart water sensor to tackle the flow of water. And an introduction to that would be water is the most precious and irreplaceable natural resource available on Earth, as we all know. It needs to be managed carefully and efficiently to be preserved for the coming generations. So there are a couple of electronic flow measuring devices based on hardware sensors available in market, but the software applications have not been developed yet. So water management is a very delicate issue and needs to be dealt with at most care. The project is concerned with the efficient management of water automatically. The significance of this model is to control the water flow and leakage to suit predefined specifications. The main objective of this project is to develop a flow control device. The use of sensor flow. So water flow sensors consist of a plastic valve from which the water can pass. A water rotor along with a Hall effect sensor is present to sense and measure the water flow. A moving fan is rotated due to the flow of water. It rotates the rotor, which induces the voltage. The induced voltage is measured by the Hall effect sensor and displayed on the LCD display. Water flow sensor with dirty water and wastewater, which may be conductive, magnetic flow meter is used. For applications such as sewage water and other dirty liquids, ultrasonic flow meters are used. The LCD display is used to pulse out every revolution of the water. The Hall effect sensor present in the device is sealed from a water to keep it safe and dry. The water leakage sensors are spot leakage detection center and zone leak detection sensor. A spot leakage detection sensor device is one of the beneficial equipment to ensure leakage and identification as soon as it takes place. The spot leakage detector has a fixed node from which it detects the presence of water on floorboards and sends immediate alerts. The zone leak detection sensor is a distinctive instrument that is used to identify water leakage emerging through ground cracks or collected water on floorboards. It accurately detects the presence of water emerging through ground bases. I would like to ask Keetana to continue the presentation.
Yeah, Brittany. Can you move to the next slide? Yeah, in case of, so now we are going to the case study. So we know that the water wastage is a global problem. It requires monitoring to prevent wastage of water. So the project is concerned with the efficient management of water, and it aims at designing the smart system for controlling and monitoring of water wastage. So here we are using Hall effect water flow sensor, which is having a board that is not MCU ESP8266. So we are then display the water flow rate and then total volume on the OLED display, and then we are integrating this hardware with the software service, and we are also using the ThinkSpeak app, which will where you get the information like how much the water flow is going on. So the water flow measurement, all those things you will get it through ThinkSpeak app, and the water flow and the volume rate can also be uploaded to the ThinkSpeak server. And then we are using this Hall effect water flow sensor, and this can be connected to the water line as it is having both inlet and outlet. Inside this sensor, we are having the pinwheel that measures how much liquid it has moved through it. And there is also a magnet Hall effect sensor that outputs an electric pulse. So using this pulse, we are detecting what is the flow of water. And then this OLED display will display the water flow rate and the total volume of the water passes through the pipe. And the same water flow and volume can be set. And the same flow water and the volume data can also be sent to the ThinkSpeak server, and which will be after an interval of 15 seconds. And we can also use Blink application if we want the immediate data. Once we have uploaded the code to the OLED display, it will start working and will show the flow rate and the volume. Initially, it will be 0 liter per minute. Next slide, Brittany. So in our main case study, we have to Gujarat as our main location, because since in Gujarat there is a place that is Rajkot, which is having lot of issues with water. So this city is in the arid rainfall zone and the high growth rate and climate and the spatial location of the city makes the water supply as a major challenging issues for the city. And here in the city, this underwater, whichever the water which is available underwater, it is not sustainable because it is associated with the risk of fluoride and nitrate, because they are having a lot of fluoride and nitrate. To meet the demand of the city, so they have ventured, the government has ventured, like many, it has used
Time is
this.
up, guys. Wind it up quickly.
Yeah, okay. So it is estimated that every liter of water requires 6 watt of energy to make it to the Rajkot, which is highly unsustainable. Inequitable and intermittent water supply has led to the unrest in the city of the past. So as far as the water is concerned, we are using this smart water flow technology and leakage, like few sensors we have used. So we use the sensors and we can reduce the water leakage and we can track the water flow as well. Next will be taken up by Guru Prasad.
Okay, this is just a small map of the regions where there's a high water scarcity, and it's clearly visible in the east of Gujarat over here. There are certain problems, and that's it. We would like to conclude with nothing more.
Thank you, team. If judges have any questions or remarks.
Yeah, so first of all, the team should learn how to prepare good presentation. These slides having a lot of content which is not good, number one. And number two, what is the analysis? How you have analyzed that water scarcity and other things? What tools have you used for analyzing that?
We went through various case studies and PDFs of various regions and how in the last 20 years we have the country has tried to deal with these things in the last 2 decades, and we try to go through how in Gujarat, especially in the Modi's term, how they dealt with the water scarcity with the use of and they became a water surplus state, frankly speaking, right now. But still, there are certain places where there are problems. So that's what we went through.
Okay, fine from my side.
Okay, team. Thank you so much for your presentation, team 17 that is. So I'll ask judges to mark the scores for the team, and meanwhile we'll have the next team ready. Team ID 24. Team members are Manjula R, Harshita N, and Bhanupriya.
We, the team Co3, are here to give a presentation, online presentation on analyzing carbon footprint in construction, building, or industry. So I would like to give first basically the introduction on GIS. So Geographic Information System is a computer-based software or hardware that make it possible or analyze personal data. It is a decision supporting system, integration of spatially referenced data in problem-solving environment. It's also called as Geographic Information System or Geospatial Information System. Mapping is a primary function of GIS, other than all. So we have choose the study area as Bangalore in Karnataka. So amount of carbon discharged in Bangalore city by different sectors. The average annual carbon dioxide emission based on 6-mile round trip in Bangalore is 974 kg for petrol cars. Chennai emits highest carbon dioxide to equivalent emissions per GDP. Followed by Greater Bangalore is more than that, which emits 2.18 tons carbon dioxide equivalent per lakhs. So in 2008, the South Asia chapter of the International Council for Local Environment Initiatives came out with the carbon emission profiles for 54 cities in the region. So Bangalore is one of the cities studied in that. So the next slides will be carried out by Manjula. I would like to hand it over to her.
So this is the map QGIS study area which we had generated. So you can see. So firstly, we just firstly carbon footprint. Carbon footprint is nothing but it is the total amount of greenhouse gases that are generated by our actions in our day-to-day lives. So in this particular project, we tried to extract the map from different sources. So the first website that we used to extract our country map and state maps was that Diva GIS. This was the website which we used to download the state maps from, and from the state map we tried to extract the city which we had chosen. And finally, we use map cruising to download the different residentials and commercial buildings from Bangalore cities, and to analyze the carbon dioxide data. So with the help of all these websites and also QGIS, we generated a map for our location.
So we would like to give the conclusion that amount of carbon dioxide being discharged to the atmosphere can be reduced by spreading awareness among each citizen of India, so that they can protect our environment from causing damages and also increase their lifespan. And
These are some of the
references links from which we have taken the data. Thank you.
Thank you, team. So now I ask the jury members to ask any questions if there are any.
I just have one small input, Aman, to the presenters. This is core 3, right?
Yes, it is core 3.
Yeah. See, when you go to your map slide, can you go to your slide number 4? See here, the representation of India is not correct. India is not shown like this in Indian maps. So you have to be very careful when you're presenting India map in public forums. So I hope you understand what I'm trying to say here. So please be careful on this.
Okay, sir. Thank you, sir.
Yeah, team, just one more thing, sir. In this, your technical content, I mean, is very less, right? That's your abstract level you have presented your work. What are the more technical content? Could be analysis part. You would included that. That's all from my side.
Okay, sir. Thank you to the jury members, and thank you presenters for your presentation. We'll now move on to the next presentation. So junior members, you can add the marks for this, which is team core 3, team ID 24. Moving on to 26, which is GeoJerry. GeoJerry, there are 2 team members, Hemant and Achitya Sarjan. They are doing MTech. So once you are ready, please let me know. I can start the timer.
So myself Hemant Kumar and my teammate is Auchitya Sajan, and we are studying in Amrita University, Kerala. And our topic is post-disaster recovery assessment and vulnerability mapping using machine learning. Problem statement. Our problem statement we took is to analyze the disaster happened in a Turkey region and the post-disaster recovery visualization in Python and the map the vulnerable areas using machine learning. And the disaster, we chose 2 disasters, that is 2019's forest fire and 2023 earthquakes. The reason for choosing the forest fire is the main objective of this hackathon is to SDG is also involved here, and our team falls under the SDG 15th goal. And there it almost mostly speaks about the forest importance and the ecology there. So we took that, and since our study region is Turkey, we all know that earthquake is a major disaster there. So we studied and analyzed 2 disasters. And our motivation was Since the 2023 disaster earthquake is very recent, not more researchers papers have been published, and that was a motivation for us. And the forest fire of 2019 is also understudied, where we couldn't find more studies, which was less export. So both the disasters was most understudied ones. So on the methodology, while framing our methodology, we were mainly concentrating about the objectives of this hackathon, that is to explore the GE and Python in geoinformatics. So we tried to, though there are so many easy methods like in GE, like dynamic map and all, giving the LULC of 10 meter resolution, we still tried GE with machine learning and manually trained to get the LULC. And this is our methodology. First, we took the about the forest fire data, the LULC with machine learning is done, and pre and post event of NBR is mapped, and pre and post event NDVI is mapped, and about the earthquake dashboard analysis with Tableau is done, and the image footprints were plotted in Python. Pre and post event split maps were done in Python, and knowledge, with that knowledge, machine learning prediction model was built, which was just a vanilla model. Forest fire, about forest fire, Auchitya will explain now.
Here we have formulated a comparison between NBR and NDVI from pre and post burn a month in the area of fire. So this was done using Sentinel-2 dataset in Google Earth Engine, and NBR and NDVI values are extracted plotted. The result that we have plotted shows that after the fire, the vegetative area have dropped. The healthy vegetation has dropped drastically, and this is doubtlessly due to the fire in the region. So in the map, you can see that in the NVR value there is a peak, and until the peak, there was a healthy vegetation that prevailed in that region. So after the forest fire, the vegetative health has also fallen drastically. So that is what we inferred from the study. So to know how the land use land cover pattern has changed after the fire, we have plotted a land cover map using Google Earth Engine using the random forest method. So this is how we classified. We classified it into mainly 4 areas, like open area, vegetative, build-up, and unused land. And this classification map is done using random forest.
And about earthquake, as I said earlier, the earthquake data. Okay, the earthquake data was collected by the Bogazi University, Turkey, and we tried to plot the CSV file in the Tableau, and it give a this is the dashboard that we created. Here the analyzing part is so much easier. This Tableau is a promising like GEE to analyze the data set. And here it is the Python. In Python, we plotted, visualized the footprints. With this footprints, this is the screenshot of the footprint that we plotted in the Turkey region. With the settings, we can play around and get analyze more about this. And this is the split map that we created. In here, this is the post disaster. Left one is the post disaster, and this is the after that. Sorry, pre disaster is the left one, and the post disaster. We can clearly see the image. We can toggle over the image and just like as we do in NV, we can visualize it. And this is the neural network model that we created with the data. Here the model was very good. Like this is just a vanilla model, neural network model, NLP model, and the results as I show here, the MAE was 0.053, and RMSE was also shows that it performs good. The error map also, so error histogram shows very less error. And the feature importance that we studied, the body wave and surface wave were correlated. And the conclusion, as Turkey is always exposed to so many disasters, its economy is falling. From the analysis, especially in these 2 studies, the economy shows there's a very great fall in their economy also. Future work, the underlying reasons behind the disasters should be studied, which will be our future work too. And more weightage should be given to the mitigation part and references. Thank you.
Thank you, team. I'll ask judges now to please ask questions if any, and we'll try to be brief. And also, add the marks if there are no questions.
Yeah, that the neural network which you use.
Yes,
So
yes,
how
sir.
many hidden layers have you used there?
Hidden layers 7, sir.
7, huh?
Yes, sir.
And how many epoch you have run in your model?
Epoch 400 epoch I did, sir. First I
400
tried with
epoch.
500, and that was too much, and I just decreased 10 by 10 and found 400 was pretty well.
Okay, fine.
Okay, sir. Thank you so much, team, which is GeoJerry, team 26, for your presentation. Will now I ask the jury to enter the marks for GeoJerry team. Meanwhile, I ask TriGeo, which is 28, team number 28, to please be ready with their presentation.
So, namaste everyone. Today I'm here to present a project that aims to identify the suitable areas for the solar farms in the state of the Gujarat. As we all know that Gujarat is a state in the Western India, abundant sunshine throughout the years. So this makes it an ideal location for harnessing the solar energy and promoting the SDG 7. So basically, the primary goal of this project is to identify the areas in the Gujarat that are suitable for the development of solar farms. So this will not only help in increasing the share of the renewable energy in the state energy, but it will also create an employment opportunity or boost the economies. So basically, the project utilizes GIS, geoinformatic system, and the remote sensing data to identify the potential locations for solar farm. So based on the several factors like solar radiation, cloud cover, temperature, the slope, slope aspects, and the other factors, which are other factors are basically the road connections, how the land is suitable for the road, near to the road, railway networks, and the protected areas. The protected areas basically consist of forest areas which are protected. So we cannot plant the solar farms there. So in the following presentation, we will provide an overview of the methodology used in the project, present the result of the analysis, and discuss the potential benefits of the solar farm. So we hope that this project will be the interest of all you. And I'll hand over the presentation to the Aniket. So Aniket will explain the further on. Aniket, over to you.
Good morning, everyone. This is our methodology of our project. So first we decided our study area, then identification of the factors which gonna affect the solar farm. We can say places which shows we are going to choose the places which shows the maximum efficiency for the solar farm. So we decide the parameters firstly, the major parameter is the irradiance, then slope, then sub parameters like temperature, LULC, then cloud cover, humidity. We considered the electricity stations up to which we are transferring the generated energy. Then protected areas from which we try to place our we are trying to place our solar farms away from these areas. So also we have mentioned the sources for the each parameters, that is we are extracted. So solar irradiance and other parameters. So these are the sources. So these are the results of each parameter. So we simply get the data and means reclassified it because we need to get the data on a certain plane, so we can arrange it and evaluate it. Sorry. Then we have resample the data, so we could bring the all data in a particular resolution. Then we make the weighted overlay for the each parameter layer, and then we get the what we can say the for extraction of the suitable locations, we take the we make the weighted overlay through the AHP, that is analytical hierarchy process. We given a certain weightage for each parameter for the for its evaluation. So these are the result of each parameter, that is the near railways, near substation. So these are the proximities for these are the maps of proximity of each parameter. So we are considering it. Then these are the maps for the temperature, irradiance, and humidity. So we are basically considering the humidity less than 50 and the temperature is greater than 25, which is suitable for the solar farms. So this is the final map of the suitable locations. As per the map, the Kutch, Morbi, Surendranagar, Dwarka, and Porbandar, these are some of the districts which is highly suitable for the solar farms.
Thank you, team Trigeo. You're on time within 5 minutes. So thank you for that. Now I ask the jury members to ask any questions or enter the marks. So we'll go to the next one, which is Spatial Hacker. Grishma and Meera Sara. Cherian, please be ready. If you are ready with the presentation. So team Trigeo, thank you for your presentation. You can.
Okay, sir. Thank you.
Good morning, everyone. We are Spatial Hackers, and our topic is developing a landslide management plan. The members are Meera Saracharian and Grishma KU. So a landslide is the moment of downslope moment of mass, rocks, debris, and earth, the soil. So the figure 1 shows the country-wise non-seismically triggered landslide, where India and the Asian countries are shown in red, and landslide risk exposure, that is from NRSC Landslide Atlas Map of India. So the Western Ghats and the Himalayan region, it is shown as risky area for landslides. So for the topic, when we got it as landslide, the topic we took as landslide management plan. So for Uttarakhand, so we analyzed LULC map for 2016 and 2020, because we identified around that that time period as the for the occurrence of maximum number of landslides. So when we checked it, these are the changes that we observed. But what took our attention is that built-up area has actually decreased. So we actually believe from we checked Google Earth Pro and certain satellite images, and we found it that it actually was the reason we might be landslides, because that time actually pointed out a number of landslides. So what we inferred is that unless we protect, restore, and promote a sustainable use of terrestrial ecosystem, these climatic changes and disasters are prone. We will have to deal with it. So we have chosen Kamoli, Uttarakhand. Actually, this figure 4, it is also taken from NRC Landslide Atlas of India. This actually shows Uttarakhand's major landslide prone districts. Out of that, we have taken Kamoli, because in 2022 and 2020, it's a region which experience landslide in a row, like every year it is prone. So we chose Kamoli as a region of our interest. We actually thought of taking Uttarakhand as a whole, but we were using GES platform, and due to computational limit, we took Kamoli district, and we prepared a landslide susceptibility map. It actually speaks of the likelihood or probability of landslide. The methodology that we use is we analyzed LULC changes and chose our study area. Using NDVI, TCC, and FCC, we identified landslide and non-landslide points and trade random forest classifier according, and we developed a landslide susceptibility map. These are the maps we plotted. The landslide inventory, that both like landslide points and non-landslide points is shown as this figure. And then we used TCC, FCC, both pre-event and post-event. And we also used NDVI maps, both pre and post. Then we used DEM, then slope and aspect for analyzing the region. And using all these, we plotted a susceptibility map. These are the references that used. Thank you.
Thank you, team Spatial Hacker, for making this quick. So thank you for your presentation. If any judges have any questions regarding that topic.
Yeah, Meera.
Yes, sir.
You have not concluded your work, right?
Sir.
Methodology only we end up, right? Number one. Number two,
Sir.
what type of data have you used?
We used Sentinel 1 and 2, then DEM data.
But you did not mention that.
Sir.
You have to be right. You have to include in slide, right?
Yes,
What
sir.
are the tools have you used? What are the data set have to use right now? With
Yes,
the
sir.
proper, the web link has to be given, right?
Yes, sir.
Okay. And then how you generated this map, landslide map?
That we used like for random forest classifier for classification. We classify data as like landslide susceptible and landslide non-susceptible.
Mm-hmm. So why did not try to maybe some other approaches? Because these are the not end-to-end approach, right?
Yes, sir.
Okay, explore in better way.
Yes, sir. Thank you, sir.
Okay, fine.
Okay. Thank you, sir, for your feedback to the presentation. Now, please enter your marks in the sheet. We'll move on to the next one, Forest Mapper, Team ID 30. If you guys are here, Vikas and Neeraj.
Good morning, everyone. This is Team Forest Mapper, and our topic was spatio-temporal urban sprawl and land resource monitoring using remote sensing and cloud computing. So let's begin with our introduction. So what is urbanization and why it happens? So the urbanization is any type of built up done by human beings for their requirement. It may be school, house, hospital, roads, factory, or any kind of built up required by humans. Here the Sustainable Development Goal 11 and 9 coming to light. Because not every built-up is favored by Sustainable Development definition. We can say this because built-up done by us will replacing any of the will replace natural resources like forest, or rivers, or any wetlands. So taking care of them, we need to make certain rules and policy and awareness among the people to deplete less these resources in order to build their things. So this is our objective. We have used big geo technique and apply appropriate tool for analysis of urban growth and compare those things with suitable machine learning approaches, and to analyze the possible solution to deal with the SDGs. And this is our study site, Jharkhand. And the data set used by us from Google Earth Engine, we have used Landsat 5 because the data was available from 1992 and till 2001. And then we have used Landsat 8 till 2021. And then we use night light data because it is also indicator of growth of human population, and also we have used GHSL population layer data. So these are the flowchart of our methodology. So we have used Landsat data. First of all, we have taken the sample point using Google Earth Pro, and then these are the sample points and training and testing point we have explained here. And then the model was trained like random forest supervised vector machine, classification regression tree, and then we get the classified image, then we generate a confusion matrix training and testing overall accuracy, and when we find the kappa is more than 0.9, then we proceed further, and then we generate a classified image using kappa with the highest kappa, and then we try to find out the change detection, and using GHSL population layer from GHSL website and night data, we have generated maps for the urban growth. And next part is taken by Komal Kumari. Komal.
Good morning to all the jury members and your past participants. So next slide, yeah. So we compared all the machine learning models which we can do in Google Earth Engine. So it was observed that the random forest outperformed because of its ensemble property with an accuracy of 95 to 97%, as well as the copper coefficient we obtained was around 0.94 to 0.79%. So we used random forest for our classification purpose. So it is like for 1992, 2001, 2013, and 21. So from this classified map, we can see that the reddish portion is for urban sprawls. So with due course of time, we can see the change in urbanization. So this is the validation or error matrix obtained from the classification. So this is area prediction. I have highlighted the built-up portions where we can see around something 7.48% build-up of the total geographical area was obtained in the last 2021 year, which was earlier 1.71%. Next. So this is the change detection map where the gray portion represents the unchanged portions, while the red portions are the portions where the urban has changed, urban growth has occurred, and the other respective classes like green for the forest areas which have been like changed in due course of time. So from this table, we can see that the built-up portions, the built-up row defines the area which was unchanged built-up areas. Otherwise, the water other like in due course of time, fallow has the change most contributed to the built-up area. Next slide. Okay. So this is the just to represent it clearly. So this is GHS nightlight image which was obtained from the website, and we have mapped it in QGIS for the representation, or we can say it validation with the Google Earth Engine image, classified image. Next. So coming down to results and discussions, so build-up increase expanded to 7.48%, which was earlier 1.7%. So barren land decreased from 15.35% to 2% due to expansions and forest in forest lands. Then random forest performed the most reliable in this classification. This information will help to stakeholders and decision makers. So coming down to conclusion that a cloud computing platform like GE is the best platform I can see from my perspective in the case for studying urbanization, and the results will definitely help policy and decision makers to plan sustainable urban development and smart city growth. Thank you. Next slide.
Okay, thank you, team Forest Mapper. You went beyond 7 minutes, so I request other team, which is last team, also to reduce the time within 5 minutes. I ask judges to ask any questions, or else we can continue next. Thank you, team, for the presentation.
Thank you. Thank you.
Yeah, just one thing wanted to ask.
Yes, sir.
Okay. Can you go to that? How you computed change direction?
Yes, sir.
From 1991 to 2021.
So in Google Earth Engine, we took samples, polygon samples of the particular class, and then we applied
what
classification.
algorithms they are using for generating the change map?
Sir, random
Any
forest.
idea?
Random forest, sir. Random forest, sir.
Random forest will not give you the change analysis, right? It will give you map only.
Yes, sir.
Okay, just read that, right? Go a little deeper to understand that how the change detection algorithm was used in backend. That would be better.
Oh, okay, sir.
Yeah. Fine.
Thank you, sir. Thank you, team Forest Mapper. We'll now move on to Aqua Squad. Team 33, if you guys are present, please share a screen.
Good morning. Hello, Namaskar. This is Team Aqua Squad. And I'm Sir Vijay Suryavanshi. My teammates are Alobeni Kikon and Diana. And these are the outline of my presentations. And the problem statements are: the monitoring and evaluation of quality of the groundwater would be essential and beneficial for the users, as the quality of the groundwater is declining in the coastal regions and contaminating the grouper river basins. This is the study area which we have selected for this study. And here the physical and chemical parameters of grouper river basin has been assessed on site. We have been on the site for the post-monsoon season 2021. And the approximate drainage area of the catchment area is around 840 square kilometers, and the annual average rainfall in the basin is 3,100 mm. And this is the 15 water quality parameters we have assessed. 7 are physical parameters which we have assessed on the site by using a multi-parameter water quality testing machine, and the rest of the chemical parameters we have assessed in the laboratories by titration process and by other methods. And this is the water quality indexing equation which we have used, which was developed by the Browns in 1972 for assessing the water quality index values of these areas. And here in this DO and TDS, that is the dissolved oxygen and TDS, plays a really vital role for the assessment of the water quality of the river and basins. This is the type soil type and rain gauge stations in the basin. So there are majorly 3 rain gauge soil types are present in the study area, that is clay loam, sandy clay, and sandy clay loam. And there are majorly 4 rain gauge stations covers in and around the Rupura River Basin, and which has annual average rainfall is around 3,900 mm. These are the results and discussions. These are the special distribution map which are prepared by using a QGIS software, and pH, ORP, DO, EC, TDS, temperature, and salinity. So here we are showing the bar chart representation of the physical parameter of the groundwater assessment with respect to the desirable and permissible limits. In this study area, the DO value is a bit of higher in a few areas, few locations. Total 10 locations we have assessed for the monitoring of the water quality assessment. In that, 7 are water quality and 7 are chemical. So this is the for the chemical parameters, we have prepared the special distribution maps of bicarbonate, calcium, total hardness, chloride, sodium, potassium, and sulfate. Similarly, we have prepared the bar chart representation with respect to the desirable and permissible limit based upon the BSI Indian standards 2012. This is the final maps. This is the final water quality status and ranges. As I mentioned, the 10 sites has been assessed, and water quality ranges from 61 to 1020. The lowest water quality represent the poor water quality, and the highest value represent the excellent water quality. So in the final results, the water quality status of the group of river basin as per the water quality index map representation, which was developed by using QGIS software. So here, more than 50% of the water quality, the basin is falling under excellent water quality condition, and 40% of the water quality is falling under good quality water conditions, and only 10%, which is only one site which is near to the agricultural areas, the agricultural pesticides and all. The groundwater quality is bit of deteriorating in this location. Otherwise, overall the water quality in this basin is excellent and good conditions, which can be not having issues. This analysis has been done for the post-monsoon season 2021 for the one season only, and around 10 locations we have taken the groundwater samples. So the wells we have been assessed, and 7 parameters we have taken on the site, and the rest of the 8 chemical parameter we have performed in the department laboratory in the NITK. Here, as I mentioned, the lowest and highest water quality index ranges is 61.24 to 120. And the finding of the studies declared that groundwater quality of the Gurupara River Basin in post-monsoon season excellent condition, with 50% of the well locations falling under excellent water quality conditions, and only 10%, which is only one location, is falling under poor water quality. So, well, these are our selected references for the study we have done for the as per the assignment given by the jury. Thank you, and ಧನ್ಯವಾದಗಳು.
Thank you, team, for this presentation. I ask jury members if you have any questions.
Vijay, I have a question for you. You went through this detailed presentation. Can you tell what part of it you did as part of the hackathon?
Yes, this is SGD6, that is water quality team. This is SGD6, water quality and climate changes.
I mean, the hackathon was yesterday, no? So I'm just trying to understand which part of your presentation you have included in the hackathon yesterday.
Yesterday, I think around 6 o'clock, I guess. Sorry, I didn't get your question. Like, what are you trying to ask me? I mean, when did I perform this? When did I have done these things and what?
My question is, this is part of a IEEE student hackathon.
Yes, yes.
So I'm
Yes.
trying to understand what you presented here. Was it worked out during the hackathon, or you're presenting something
No, no, no,
before
no,
the
no, no.
hackathon?
This data I have taken before, but everything we have done we have divided in the three teams. So we have performed everything in yesterday itself as a part of this hackathon only.
Okay, Team Hacker Squad. Thank you. Thank you for the. Thank you.
Thank you.
Good morning, everyone. I'm Ananya and my teammate is Kirtana. We're both from the National Institute of Engineering, Mysore. Our team is 23, Star Platinum. So our topic of interest yesterday was we wanted to study the transportation infrastructure in an area. So I think Kirtana will elaborate a little more about the introduction. We try to compare the transportation facilities of the area, and as it is it's a major contributing factor towards the economic development of the country as well as improving the GDP. So our topic lies in the same it comes under SDG 9, improvement of infrastructure and their economic impact on the country. So we are the area that we chose is Shinjuku, which is one of the busiest regions in Tokyo. So this place is like the major economic hub of the city. And we decided to go through the road infrastructure of the region, since they also have railways and roads which are very well interconnected. As we thought, since we don't have too much time to do railways as well as roads, we only focused on the road portion of the analysis. So first what we did was we found the coordinates of the region we were analyzing, and we put in that data into GeoJSON, and from there we drew the boundaries of the area, and then added the line data to represent all the roads, and then we saved that and exported all that data to Kepler to generate our final map. So this is the area that we got, and this is the network of roads. So as you can see, it's a very densely populated region, and it has a lot of roads in this area which are very widely connected. So the area was about 14 square kilometers. So that was our result. And we with according to us, we found that the road density of the region, as it was very high, that's what is impacting the economic transactions of the region. So that is our conclusion. These were our references. I think that's it. Thank you.
Thank you, team, for making it brief. So this was team Star Platinum, which is 23, Ananya, Kirtana. So any judges, and if you have any questions, we can take, or else we can move on to the next, which is Cosmic Trio.
No problem. Go ahead next.
Sure. Thank you. Thank you, team. Cosmic Trios, if you are available, can you share?
My team name is Cosmic Trios. Topic is estimation of crop yield due to climate change for Madhapatna village, Kushal Nagar. Remote sensing. Remote sensing is the acquisition of information about an object or phenomena without making a physical contact with the object, in a contrast to in situ or on-site observation.
You can skip it. This is basic step, right? You not to waste time.
Climatic changes. So use of GIS in agriculture. GIS agriculture enables to farmers to map field data, organize and analyze it, and monitor their crops remotely. Currently, we study the Madhapatna village. It covers a 2.6 square kilometer area, latitude 12 degree 28 minutes and 1.200 seconds, and north longitudinally 75 degree and 58 minutes 1.2108 east. This is the map, and we use the Landsat 8LOI, and it is the data used for Landsat OL89 and soil map crop details from field data. It is the soil map study of area Madhapatna. NDVI value and yield of paddy. This is the ranges. High NDVI value is 0.35967 yield is 5,916 and low NDVI is 0.10846 and yield for hectares 1783.93. Average NDVI is 0.23406 and yield for hectares 3,850. This is the graph. Yield range with respect to area. Conclusion. In regression study, NDVI value of the image areas identify the paddy crops is used as a major independent variable for yield estimations. Roads and barren areas have been marked. The atmospherically corrected images log transformed NDVI has an advantages in yield estimation. For yield estimation, multiple regression analyses are employed in the addition of the NDVI value. Variables such as field location, irrigation capacity. All 3 years final yield estimation models are statistically significant at 99% confidence. All of the models independent variable are also significant. The final yield estimating model has regression value of 0.9739 in 2023 and regression value of 0.9635. In 2083, there is a Madhapatna population is 15,326 due to urban areas or less urban areas. In 2023, 21,000 population due to urban area is high urban areas, so the crop yield is less, and we have to provide a high production. The comparison of the two tables 2 and 3 shows that higher yield covers a smaller area, although lower yield also covers a smaller area. The yield in 2013 was relatively poor, but the yield in 2023 is higher, although the sowing area is smaller due to urbanization. The identification of the crops is an step estimating crop yields and managing agriculture resources. In summary, remote sensing and GIS technologicals are widely used for crop identification, crop condition assessment, and crop yield estimation. They provide accurate and timely information that is critical for managing agriculture resources and increasing crop yields. These are the references. Thank you, sir.
Thank you, team. So we are already running out of time. We have passed 20 minutes.
Just I'll give quick suggestion that you need to careful while preparing the presentation slides, right? Your slides are not up to the mark. You're just cut paste you're doing.
Okay, sir. Thank you for your comments. So all the participants, all the team members, please take these feedback in the positive way and try to improve, especially those who are in BTech. There's a long way to go, and you can actually improve a lot. So now I thank. So with this, we end the presentation. Those who have not presented, please submit your presentation. We deeply apologize because we are already running 25 minutes late from the scheduled time. So please submit your presentation, and we'll take care of giving you appropriate marks. So the results will be around 1 p.m. So to evaluate the results, now I thank first the jury members, Dr. Shyamlal, Dr. Ujjwal Marma, Guru Datta sir, and Dr. Shilpa for your valuable time. I know it is already very late, but please, thank you so much for having evaluated the results. Your inputs to the students is much appreciated. Thank you, sir.